Okay, so what we're supposed to do here is we're supposed to verify the identity algebraically. We haven't done a whole lot of verifying. I've kind of skipped over most of them, but these ones we're going to go ahead and do. So basically, I got to get the left side to look like the right side. And notice, we're doing an addition thing. I'd like to be able to cancel things, so I need to get it into products. So we're going to go from, looks like we're going to do a sum to a product formula, right? So let's try that. So on the left, we're going to just write down the left side, and we're going to try to get to the right side. So what do the sum to products start with? 2. But so the top and the bottom are both going to get a 2. All right, let's just deal with the top now. So we've got sine plus sine. So what is that? What do we? Two things do we end up multiplying together for sine plus sine? Sine and cosine. The first one is a plus, and the second one is a minus, and we divide them both by 2, right? And then we plop in a t and a 3t and a t and a 3t. Okay. Don't get too into the simplifying yet. All right. Just hold off on that a minute. Okay. What does the cosine multiply into? Cosine plus cosine. What does that multiply into? Cosine and cosine. Okay. And then, but don't try to think you know it, right? Because it's going to change. It'll just when you think you know it, it changes up. So always check your chart, especially if I'm going to let you use that on the test. Okay, and I'm going to let you use it. All right. It's always plus first, minus second, right? And we're going to plop in t and 3t and t and 3t. What do you notice from this step? Don't these second cosines, they're identical, cancel? Awesome. Is there anything else that cancels? The 2's. Okay, so now let's simplify what we've got left. It looks like I've got sine. What's 3t plus 2t, or plus t, sorry. 4t over 2, and I've got cosine of what's, again, 4t over 2, right? What's 4t over 2? 2. So I've got sine of 2t over cosine of 2t. What's sine over cosine equal to? Did I get what I wanted? Is that what we needed up here? Yep. So we have officially verified it. Again, the work in between is what I need to see on this test. And remember, the test is Friday, right? If we don't do better on it than the last one, do we get to use our final grade to replace? No. Okay, yeah. The 2's cancel, yeah. In the front. All right, we go to 25, 23. Okay, let's look at 24. And again, I could be using any of the properties we had in this section here, okay? All right, so it looks like I've got to get this one into cosine 2x. I'm going to start by factoring it because I really don't know what else to do with it, but I know I could factor that. So let's try factoring the left side. What kind of factoring is it?
Grouping.
It's not grouping. It's a binomial with a minus sign.
Difference of squares?
Yes, difference of squares. So I know what's the square root of cosine to the 4th? Cosine squared. Write down cosine squared. And then what's the square root of sine to the 4th? Sine squared. We make 1a positive and 1a negative. All right, I want you to go in and let's think about what these turn into. Look up at the windows. What's cosine squared plus sine squared? 1. Good. All right, now I want you to look in your book. Look at what you have to get to. That would be like a double angle, right? I want you to look at your double angle formulas. See if you find this. So everybody should be looking at your double angles. Did you find it? What does it say? Cosine 2x. Isn't that what I wanted? So get rid of the 1 in front and you've got it, right? We verified it. It was literally like 2 lines. So it's not like we're doing a million steps of verifying. It's a couple of lines. Okay. Oh, the next one's a little uglier. All right. So I am going to I'm going to attempt to get the left side to look like the right side. Okay. In order to accomplish that, I'm going to probably end up having to use the double angle twice. Okay? So we're going to go back to our double angle identity. I'm going to rewrite this to begin with. Because remember, double angle, in order to convert, it has to be 2 times something. Can't I break up the 4 into 2 times 2? So sine 2 of 2 beta. Alright, this is going to be the u. Alright, so I want you to go look at your double angle formula. What does sine turn into? 2 sine of u cosine of u, right? What are we going to put in for the u? 2 beta. So everybody get that part written down. Okay, let's look at where we're supposed to go with this. Okay, I need to have a sine times a cosine. Looks like I kind of have that set up, right? But I also need to introduce this thing in here. Okay, so I'm going to use this line here. I'm actually using the double angle twice in this line. I'm going to reduce both of those using the double angle, because it is a double angle. It's 2 times beta and 2 times beta, right? So let's do the double angle on this piece. Drop the 2. So we're going to drop the original 2. What does sine of 2 beta turn into? What are we allowed to put? 2 sine beta cosine beta. Alright. Then let's look at the back part. Go look at your, whatchamacallit again. Look at your double angles. Look at cosine 2 beta. What does that turn into? Okay, that's one of them. Look at what you have to get to, though. I need something with signs in it. Keep going. What's the next one? There you go. Isn't that what they wanted us to get? Yeah! All I have to do now is multiply the 2 and the 2 together, and don't I have the right side of the equation? Alright, so you got 4 sine beta cosine beta times 1 minus 2 sine squared beta. Alright, 2 more. Alright, I'm gonna go ahead and erase. I'm gonna go ahead and go to the next one. Alright, we have to verify this one. It looks like I'm going to use a sum to product, right? Because I've got sums, and I have to get it down to just a cosine, so let's see if we can cancel some stuff with the product. So, it looks like I have to do that twice, though, right? Because I've got 2 sum to products there. So this first one, what does the sum to products start with? Oh, this one's weird. This is a really weird one. Okay. I don't have 2 sum to products. I have 1 sum to product. This is going to be a U, and this is going to be the V. See how that looks weird? Right? That whole thing is the U. This whole thing is the V. All right? Here's our sum that we're going to use. All right, so what does our sum to product always start with? 2. I've got a cosine plus a cosine. So what does that multiply into? Cosine times cosine. Notice I left space, right? I know I've got to divide by 2. The first one's always a plus and the second one's always a minus. Alright? And then I'm going to plop in pi over 3 plus x and pi over 3 minus x. We could put parentheses there, but you don't need them because there's nothing to distribute, right? This one is pi over 3 plus x, not just times x, so plus x. And then this one is pi over 3. Notice I put parentheses. Why did I use parentheses this time? Yeah, we got to distribute that negative, so I'm going to go ahead and do that with a different color. So I'm going to distribute in a negative pi over x and make that positive x. Alright, let's see what we can do to simplify it. So let's see. First of all, not yet. I'm going to leave that 2 there. So let's see. What is pi over 3 plus pi over 3? Hey, well, let's do this, in fact. How many pi over 3s are there? 2. Let's do 2 times pi over 3, right? That's the same thing as pi over 3 plus pi over 3, right? What happens with x and negative x? Cancel. And then look at this. I've got an over 2. What happens with these 2's? Cancel. So don't I just get 2 cosine of pi over 3? Alright, now let's do the back part. I'm going to do the back part in a different color. Alright, so I'm doing the back part now. Let's see. What's pi over 3 minus pi over 3? 0. They cancel. And then we've got x plus x is what? 2x over 2. What's going to happen? The 2's cancel. So I've got cosine of x. I'm supposed to get it down to a cosine of x. At least I now have a cosine of x. I probably need to evaluate this thing, don't I? So I want you to go to your unit circle. What's the cosine of pi over 3? 1/2. What happens with the 2 and the 1/2? They cancel, and I've just got cosine of x. Alright. We're 2 lines away from being done. The next one's only 2 lines. We're going to skip 28. Okay. Alright, we're supposed to rewrite the function using power-reducing formulas. Okay? So, in order to use power-reducing formulas, I need to get it into a squared. So everybody, first of all, find the power-reducing formulas on your chart. I think they're in the left-hand column, am I correct? They're in the right-hand column? Okay, so find the power-reducing in the right-hand column. Every time I do power-reducing, I need a square. So I'm going to break this into sine squared x and sine x. And I don't know why. I don't think this looks simpler, but they're just wanting us to rewrite. They're practicing the rewriting process. So what can I put in for sine squared and power-reducing? We're done. That's all they want us to do with this. Okay, I was just practicing using those power-reducing. Alright, I said we're going to skip 28, right? So we're done. Okay. So I posted the homework for you.